Hello and welcome to Sydney Serverless. It has been quite the year 2021. Welcome to 2022. How's everyone going out there? I hope you're doing well despite all of the challenges associated with, Omicron cases and all the rest. It's been with a lot of apologies that we haven't been meeting as regularly as we would have liked to have met over the past 6 months. Definitely, I think everyone's had a lot going on in their personal lives. Me personally, I did a big house move. Family of with two kids in a two-bedroom townhouse. We just decided to get a little bit more space, and that occupied a lot of my free time in the second half of last year. So apologies for not having more regular meetups, but I think 2022 is the year of regular serverless meetups, in-person serverless meetups, and fingers crossed, an in-person serverless days ANZ. I think that'll be amazing because we'll see online meetups are fantastic. Allows folks from regional areas to sort of join in on the fun. It's really awesome to be able to sort of get together in person and share what we've learnt doing application development in a serverless manner. Today we've got a really exciting meetup. We've got first up, we've got James Weakley presenting. He's a seasoned programmer. A lot of the new tech folk people would recognize him instantly. So he's he's a seasoned IT professional, and he's created his own startup called Omnata, specializing in, I guess, kind of like the reverse ETL space, although he was just explaining to me where his focus is a little bit different than that these days. But there's a data framework called dbt. They hosted a conference called Coalesce last month, and he did a bunch of awesome work there, building a sort of an app where you can sort of design graphics and stuff like that. And he built it all serverlessly. So that's going to be a really fantastic talk that he's going to bring to us shortly. And then after that, I'm going to be taking you all through my reInvent recap, just what are the thoughts that I have on what was announced last month, and sort of what I think is sort of really applicable to a serverless audience. So really looking forward to that. So without further ado, I'm just going to add James to take us through his deep dive on a fully serverless Slack game. Welcome, James.
Thanks, Peter. Thanks for the intro, and yeah, happy to be here, and definitely share your sentiment about hopefully getting those meetups and conferences back in person sometime this year. But in the meantime, yeah, happy to do some more remote sessions, and looking forward to hearing about reInvent. It's difficult for anybody to keep up with what's happening, so I'm looking forward to that as well.
Awesome. I'll let you take it away.
Sounds good. So this presentation today, as Peter said, it's about a specific project that we ran at Omnata late last year, and specifically how it leveraged serverless technology in AWS. So I'll go out on a bit of a limb here and say that, if you're into serverless like I am, then you're probably also interested in, the way that serverless allows you to prototype and prove out and then evolve an idea quite rapidly. And so before the technical stuff, I'm going to talk a little bit about that. Pardon me. Why we decided to build the game, and the ideation process. So if you're here just for the Lambda part, maybe you can tune out for the first 10 minutes. Then in the technical part, I'll show you an example of how with serverless you can have more flexibility than ever when you need to isolate some kind of workload. So the whole talk and the demo will go for about 20 to 25 minutes, and then we can do a little bit of Q&A if we need to at the end. A little bit about me. I started out in and around software development, but I do have a fairly broad interest range. So at different times I've focused on infrastructure and security and quality, also on leadership and commercialization. So all of this led to me founding Omnata a little over a year ago. And I've done some work in the open source space as well, particularly around Snowflake management and dbt. Omnata, our main product, is really for companies who have adopted and invested in cloud data platforms. So we allow CRMs like Salesforce and Zendesk to access customer-related information straight out of that data platform. And so if you're the type of company who either has a cloud data warehouse like Snowflake or BigQuery, we can plug your CRM straight into that. Alternatively, we support Rockset, which in turn supports most of the popular public cloud data stores like Dynamodb, S3, Kinesis, Kafka, and so on. And it provides high-performance APIs over the top of those, which we can connect to. On the app side, we support Salesforce and Zendesk with others on the horizon. So hit me up in the Data Engineers Slack or on LinkedIn if this interests you. The game we built was part of our sponsorship of a conference called Coalesce. So it's an online conference hosted by DBT Labs, who are the creators of dbt, which is a popular open source tool for managing data transformations in SQL. So it's really the main conference dedicated to analytics engineers and generally this new wave of data practitioners. So we're a DBT Labs partner. Our product is really built for this audience, and we've got open source DBT packages for the community to use, and even one for our own product. When we saw that Coalesce was open for sponsorships, we knew we needed to do something there. We are an early stage company, so this would be our first conference. And I'm a technical founder now. My background's mainly been in solving problems in industry and architectural decisions. I've never really worked in marketing or events. So this was a little new to me, how to approach this. But I have attended a lot of tech conferences in my career. So I knew there was always the interesting talks, deep dives into new technology, roadmap stuff that was interesting. But the sponsor who's advertising their product at the conference is always a tougher sell. And, typically this is done in the in-between time at a physical conference, and you've got a bunch of vendors sort of vying for your attention in various ways. But for an online conference, how does this work? My suspicion was that if you just tried to slot yourself into the lineup of speakers, then maybe you have an uphill battle compared to the other talks, and maybe a lower ROI, just because you've got a less captive audience for an online conference than a physical one. I've certainly been in the situation where you're in between talks and you just do some laps of the vendor hall just to kill some time. But in an online conference, you're at home, so you don't really have to do that. You can go and put some washing on or catch up on some work. So I thought if this is about awareness of our company, then we could just take a bit of a risk and try something new and build an online conference experience that's purely just for enjoyment for that audience. And if it turns out to be popular on its own merits, then people will at least know we exist and be a little more aware of us. Of course, if it's not popular, then it could be a waste of time, but I'll show how we mitigate that a little bit in the way we approached it. So the conference took place on Slack, which is a collaborative visual medium. So I was thinking it'd be kind of fun if we could let people drive something through Slack messages or commands, and then immediately they and everyone else can see the result. So this was sort of the initial boundary of the idea. Honing in further, ideally it's related to the conference, so most likely needed to be SQL oriented in some way. And then riffing on that idea a little bit, what's a fun thing you could do in terms of instant feedback, and arrived at the idea of drawing pictures. So we essentially represent a 2D canvas using a database table with 3 columns. So there's a row for every X and Y possibility and a third value for the color. And then every time you issue a SQL statement to update the table by modifying the color value of some records, the bot will automatically redraw the canvas for you in Slack. And so you don't want to be, tapping on individual pixels. If you want to draw something impressive, you've got to find a way to update ranges of pixels via SQL, because you can have up to 1 million pixels on a canvas. And so if you want to draw shapes, you got to think about Cartesian geometry. What equation would I need to update a range of records the way I want? You might use some Boolean algebra on some of the numerical properties. So then you have to translate that into SQL to do the actual work, and that's kind of the fun of the game. So conceptually, I see it as partly a sandbox game in that there's no real objectives. In that sense, it's a little like Minecraft. A lot of the fun is really just showing other people what you thought of to do. And then sometimes, learning curve is a constraint, and that was true for us. We only had a brief amount of time to get their attention and draw them in. So we wanted to reuse some things that they're already familiar with. So in the sense that Rocket League sort of had you follow the rules of football through the interface of driving a vehicle, two sort of familiar things combined in a novel way, gives you the rush of the new experience without all the cost of building this new knowledge. And so that was similar for us in that, we reused their SQL knowledge to get them to draw a picture. Hopefully that would be a draw card. And then finally, there's this emergent gameplay where you end up with complex outcomes from fairly simple basic rules. So in games like Just Cause, you can attach a grappling hook, and the other end to a helicopter and one into a car, and the physics engine will let you do that, and you can see what happens. And the whole point is that the players of the game do things that the designers never really considered. And so with SQL Draw, you just get given this whole SQL engine to do whatever you like with, and different people have very different ideas. For example, in that bottom picture there, it's a fractal that the CTO of DBT Labs came in and created just by using a bitwise AND on the X and Y axis, which I thought was cool, something I would never have thought to do. And here are some examples of pictures that people created during the conference. And some of them were quite elaborate series of SQL statements. Some of them were extremely elegant, one simple statement to draw the whole thing. And people tended to take it in very different directions, which was really cool. But the tech stack, fully serverless eventually. And I really feel it's a testament to how far serverless has come over the years. What was created by one developer in a very small amount of time with a very limited budget probably wouldn't really be possible prior to serverless. But before going ahead and putting in a lot of effort to architect something elaborate, which is usually a common instinct for a developer, I decided to validate the concept first. So I learned this the hard way over many years of too much upfront R&D every time I had an idea. So keeping it very fast and simple with just a few Python scripts and a couple of Lambdas and an RDS instance, I was able to throw together in a few hours I was able to build a quick MVP and just show my co-founder the idea. He said it was a cool idea, and he's usually pretty honest, so I gave it a small tick. Then we booked some time in with the DBT Labs team, the people running the conference, just to gauge their interest, and they said it looked pretty cool, and they'd be happy to have it at the conference. So that was a slightly bigger tick there. But before we got right into it, we set up a shared Slack channel and invited a bunch of their team members in, and they got to play around with it themselves, and we got to see them experience it for the first time. And they all instinctively tried very different things. We had tic-tac-toe games, we had the fractal, we had color gradients, all sorts of things going on, and they gave it a very enthusiastic yes. So at that point, I thought it's worth improving this to be more conference ready. Now, in this project, we wanted something that could scale easily if it had to. So we really had no idea how many users there were going to be. There was a 4-day conference that was set to have about 10,000 attendees. So on one extreme, the game might be a bit of a flop and only 5 or 10 people have a short go. But on the other extreme, the entire conference might jump in all at once. So it's a little unknown. In either case, at some point at the start of the conference, an email would go out to invite everyone to join the channel and have a look. So we wanted to at least be prepared for that moment. Now, a central RDS database is tricky with serverless at the best of times because they aren't really designed for an unpredictable volume of short-lived connections. Typically in the old days, you'd use a connection pool from your app. So you have all this great scalability coming in through the Slack Events API, hitting your Lambdas. But each time you connect to RDS, it has to allocate some memory, and you have to be super careful with the number of connections and the connection leaks. And typically that involves allocating a large amount of memory to the instance, just from the number of connections point of view. And to add to this, the whole point of the game was that we were going to let unknown users from the internet run any query they liked. And Postgres doesn't let you really allocate resources to different users or connections. So that could be a problem. And these people are data analysts, and they spend all day running queries that require Snowflake or BigQuery to process them. So fair to say they know how to place load on a system. And so elaborate queries could be happening, or probably will happen. And then performance aside, it was going to be tricky to prevent malicious queries. So initially I just had a Postgres schema for every artwork that got created, but there was some ways around that I'm sure people would have figured out. So in these situations, we typically have to look at where the contention really is and what we can use to deal with that. So the actual pixels of each artwork really sit in their own table and are really little islands of data. So it's not like you could have 10,000 people contending for the same artwork. We did need the Postgres engine because it's kind of core to the game. It's really the only suitable database engine in that analysts know it pretty well. It's very mature and supports a lot of analytical functions and window functions and things like that. But the elephant in the room, if you will, is that Postgres isn't really designed to be multi-tenant and to handle noisy neighbors. So we really want it for its query engine, but not really for its any sort of centralized storage. So can we keep storage somewhere central and scalable, but move the processing somewhere isolated like Lambda? And it turns out with a bit of work, you can actually run a Postgres instance inside of a Lambda. So I'm sure you're all aware that Lambda supports layers, so you can do a Docker build if you're licensed appropriately, and then you can push the image to Elastic Container Registry, and then you can tell your Lambda to use it as the base, and then it'll be available, within the runtime. After installing Postgres from the package manager, if you try to start an instance inside the Lambda, it gives you a bunch of errors. That's because Postgres, if you have all the defaults, it wants to reach into the operating system in ways that Lambda doesn't really permit. So you do have to build it from source yourself with a few flags switched off. So inside the Docker file, download the build tools, you download the Postgres source code, and then you have to set a couple of compiler flags to tell Postgres, mainly not to ask the operating system to notify it if its process dies, which is a Linux kernel feature. So instead, it'll just poll instead. And then you also have to change the temp folder location, change the shared memory type, and also just disable the parallelism of Postgres, because Lambda is going to be our parallelism for this. So after doing that, Postgres actually starts. Almost surprised myself when I saw it, start accepting queries the first time. And I'll just show you a quick example of me drawing something in the game, and then we'll talk about how it works. So this is just our test environment here. What we can do, this is the game, the bot that runs the game. So we can request a canvas. And so every command we hit from Slack here is coming through to our Python lambdas. So it's just dropped a new canvas for me. Now we just have to run a query. So if I just say update set color equals, I'll just grab blue, bit of a nice blue. And then I'll just restrict it to between 20 and 80, and Y between, 30 and 50. And so that's gone and redrawn that, and I can do a few other things. I could draw a circle. Oops. And I can clear it, or I can undo things, and you can do some more fancy stuff as well, like a little bit of texturing, a textured circle. There's a bunch of little tricks we can use. So that's the game in action. You can see you kind of get this instant or near instant redrawing. So if I just sort of step through what the pipeline looks like as that executes. So we have most of the Postgres tables stored metadata. Like, for example, does the Slack user actually own that artwork? Are they allowed to update it? Things like that. So all of that just moved into DynamoDB because it's much more convenient to read and write those types of individual records. And then later on, we started capturing things like Slack reactions and use them for a voting system. The actual bitmap pixel values we actually don't need at the record level outside of that embedded Postgres instance. So those we actually just dump and load between S3 and the Lambda. So when the Slack comment comes in with the SQL query, it first hits this Python script. We do our permission checks and things to Dynamo, and then we spin out, like the Lambda creates or spins up the Postgres instance if it's not already running. then it grabs the bitmap pixel data from S3 and pops it into Postgres, and it runs the query, and then it retrieves the pixels back out, and then it renders it using matplotlib in Python, copies that image to S3, and then updates Slack, and then after that it stores the raw data back into S3 and just does a bit more metadata into Dynamo. So the whole process from a cold start takes about 8 seconds. From a warm start is about 5 seconds between when you hit enter in Slack to when you see the image respond. Now that's actually if your query works. If I was to try and submit a query that didn't work, you get a quicker response because most of the processing is actually generating the image. So you get errors back a bit faster. We could probably have gotten it down to less, but it was good enough. We could have shrunk the image size a bit more and maybe given the Lambda a bit more memory, but that was good enough for the game. Any questions? I can actually answer them off Slack, I think, if anyone has any. Hey, Peter.
My microphone wasn't working. Okay, back on. Well, first of all, virtual round of applause. That looked sensational. Really, really exciting. I guess the first question, just to get things underway, going back to your architectural diagram, and how you're sort of going from I've got a couple of Lambdas and a big old RDS Postgres instance. And I guess you were sort of thinking through the challenges of, connection pooling and stuff like that, and just, scalability and stuff like that. How did you go about trying to, figure out, get to that end solution? I'm guessing, you didn't have that sort of, off the top of your head. Did you sort of go out to forums or ask a few folks around, what the, were possible solutions?
Yeah, I thought of, I guess I wondered if it could be solved in RDS, in other ways before I got to that point. So I wondered if we could potentially have multiple instances of RDS and actually sort of partition the tables somehow. Maybe if you had, a pool of RDS instances that you could maybe kind of round robin stuff a bit more. I kept running into, I guess, the challenge of even if it worked performance-wise, security was a tricky one because it was a single user. Each end user didn't really have an identity in the database, and I didn't want to have to modify their query to be safe, like try and rename tables and things. So trying to kind of, and also I'd read that if you have like lots and lots of schemas in Postgres, I think that has ramifications on the file system as well. So I anticipated trouble trying to do it that way as well. Also just trying to separate, reads and writes was one possibility. But yeah, I can't remember, what made me wonder about running in a Lambda. It was a bit of a random thought. I actually assumed it would be too difficult, but I just decided to give it a try anyway. Like I said, I was almost a little surprised when the queries were running within the container. If it was any other situation and you didn't need like really flexible SQL, I would normally just use Dynamo, just because it's so much easier to just, if you work within the Dynamo paradigm, you kind of get automatic performance almost without trying. So it was only that Dynamodb doesn't support SQL that kind of left me in this situation of, you want the SQL, language, and you want its behavior, but it's common. The infrastructure it usually runs on has a lot of challenges when it comes to scale.
Yeah, I wonder if the new serverless Cassandra offering from AWS might have helped, but I guess I'm not super familiar with it. Yeah. Scott Scoville has asked a question though. Could rendering be treated as an async process?
It could be, definitely, but until you do the rendering, the user can't really get any feedback anyway. So it wouldn't have looked any different to the end user to split that out. It probably, and it's usually just rendering one image straight away. So it was kind of good enough just to leave it at the end of the one pipeline. I think if there was a way to like maybe give the users some feedback. Actually, we sort of did do that. You may not have noticed there's a few little emojis appear on the Slack message as like a status update. So the user can see when the query's been run, and then after that, when the image is being rendered. I guess if they require different amounts of memory, that would have made a lot of sense to do it that way. Like if you need a small amount of memory to run the query and then a large amount of memory to render the image, then async to a different Lambda would have made sense from a cost point of view. But it didn't really need to think about that because it's not really a permanent product.
Yeah, a couple of follow-up questions that I've got before we wrap it up. But you touched on cost. How much did this cost you? And more importantly, what was the business benefit? Because obviously, it's pretty amazing. You've put together this serverless solution. It didn't cost you a hell of a lot of time. You are the CEO and core programmer of a startup, and so your time is infinitely precious because it's how you build the software to make money for the company. But you're able to sort of carve out some time to build this. And what was the engagement like? And the return on investment and stuff like that. And how did serverless help?
Yeah, so the engagement ended up somewhere in the middle of where we thought it might be. Not on neither extreme. I wouldn't say it was a flop, but also we weren't overwhelmed with traffic either. I think we had a couple of hundred people actively using it. Out of a total number of registrations of like 10,000, but I did also notice that not many people were watching presentations live in general. Maybe it was partly a time zone thing, and I think it's part of an online conference is that the talks themselves can be a bit asynchronous as well. I have a feeling a lot of people sign up with the intention of watching them, whenever they get a chance, as opposed to live. So the there was never like a overwhelming number of people suddenly playing it, and I think that's kind of reflecting online conferences in general. But yeah, we had a couple of hundred drawings with people coming in and drawing stuff and having a lot of fun, and so it's hard to quantify that in terms of benefit, but certainly a lot of people within that DBT community probably became aware of us a little more than they did before. I was joking that I'm going to attribute every sale to that event just so that we can justify that kind of reckless marketing expenditure again in future, because it was a lot of fun to do, and I actually had a lot of fun building it. It was like, yes, it took away from building our core product, but it was also kind of a bit of a fun side hobby as well. So I wasn't ruthlessly accounting the minutes that were spent on it. I think if you kind of added up a lot of the little, I would probably, because it was like 8 months from when we pitched it to when the conference was, because that's the time frame these things run on. And I'd jump on once a week and make a few little fixes and changes here and there. If you were to add that all up, it probably did have a week or two full time kind of spent on it, just tweaking and refining and testing.
Yeah.
But I wasn't too bothered by that cost.
Yeah, life's serious enough, especially in the middle of a pandemic. It's good to have a little bit of fun, and man, I'm just blown away at how cool this is, both architecturally and just just the fun of actually seeing it live in Slack and stuff like that. So
yeah,
awesome.
I don't think anyone else will ever have a use to run Postgres inside of Lambda. I don't know that it ever makes sense apart from these very unusual scenarios. But I love that with custom layers, you can just fulfill whatever niche requirement you have for yourself, which is cool.
Yeah, no, that's really awesome. And so thanks so much, James.
Pleasure.
Where can we reach you if we've got any questions? I guess on the Data Engineering Meetup Slack channel.
Yep, that's a good spot, or LinkedIn. Either one of those two are good places.
And your company, it's omnata.com, isn't it?
Omnata.com, yeah.
Yeah, awesome. I'll just drop that link in the chat so everyone knows. Always good to support local startups. So definitely go check out Omnata. Thanks once again, James.
Cool. Thanks, Peter.
All right, folks. Now it's my turn to hop in the hot seat. You've probably met me before if you attended the Serverless Meetup or gone to a Serverless Days ANZ event or a Serverless Days Sydney event. I'm an AWS Serverless hero and have been running this meetup for a good couple of years now, along with the eCloud Guru team of Pete Sparsky and Sam Cronenberg. So it's been really good fun, learning from the rest of you, from folks like James and the like, building out really awesome, unique solutions using serverless. What I wanted to do right now is kind of help you sort of keep up to speed with what happened at AWS reInvent last year. It was a bit of a crazy time in Australia, with COVID and everyone's sort of planning their end of year holidays and stuff like that. So I think it's a really handy to be able to, I guess, just kind of have a bit of a recap that's serverless focused. So you're not sort of drinking from the fire hose, but also you're able to sort of, I guess, take a bit of inspiration to play around with some of the really cool releases that happened at the end of last year. So hopefully you do find this quite enjoyable. Cool. Just a bit of a heads up before I dive into the agenda. At the bottom of the slides, my face might be blocking it, but there's usually tags that say either GA, a preview, or there's no tag, which means it's just simply an announcement. I'll make sure to mention, which one this particular announcement is. But anyway, on the agenda, we're just going to go through the developer and DevOps announcements, serverless, of course, because we're at a serverless meetup. Some cool security stuff that's relevant to this audience, also architecture, database, analytics, and AI and ML. Cool. Diving straight into the developer and DevOps features. So first up that's gone GA is Amazon Code Guru Reviewer. Now detects hard-coded secrets in Java and Python. Pretty much does what it says on the tin. It just kind of finds if you've left a database password or something in your code. So that's generally available and super handy. Amplify Studio. So if you just want to design something real quick in the console without sort of diving deep into code, this allows you to visually configure an app backend, model data, set up auth and cloud storage. It's built on the AWS Amplify CLI. You can customize and integrate with your existing CI/CD using the AWS Cdk integration. Visually build a front-end UI with dozens of pre-built components, and also import designs from Figma as React code. So this is a preview, but hopefully it's going to go GA pretty soon. This is another screenshot of Amplify Studio, where of the UI library. Cool. Onto the Cdk Version 2. This is in preview, although it's pretty well generally available. It's for JavaScript, TypeScript, Java, Python, .NET, and Go. Main thing is it's a consolidated construct library, so you just import AWS CDK lib rather than a package for each service. So that obviously keeps your code a little bit tidier. And just one thing to note is the experimental modules are still distributed separately, and there's also the new CDK watch functionality. There's also the AWS CDK Construct Hub that's gone GA. So this is where you can sort of share with the wider cloud development community. So definitely recommend go checking it out. Like there's projects like Progen, which are really good ways of synthesizing your CDK templates, and Next.js websites. I basically use it for everything that I do these days. Absolutely love it. So if you're into your stiff drinks, CloudWatch Rum, which is real user monitoring, basically Google Analytics, AWS flavor. This is generally available. Basically, copy a code JavaScript code snippet to the header of each page, and get some really useful tracking metrics. Similarly, there's CloudWatch Evidently, which allows you to introduce experiments and feature management in application code that's generally available. Includes templating and dashboards of your features, support for front-end, back-end, web, or mobile, and even ML applications. 9 programming languages supported. So I think that's a pretty cool feature to go check out. AWS microservices extractor for .NET. So basically a tool to assist you, transforming a monolithic application into microservices. Definitely very cool for .NET developers, and that's GA as well. New SDKs for Swift, Kotlin, and Rust are in preview. If you also want to manage your AWS resources from Slack, that's now supported, like scaling your EC2 instances, running systems manager runbooks, and changes to Lambda concurrency limits. So this is in preview. And Repost, it's basically Stack Overflow, or AWS's answer to Stack Overflow. You can get AWS answers from AWS and customers. It's expert reviewed and free, so well worth a sign up, and that's generally available. AWS Bug Bust, if you want to get some street cred by being, the #1 bug buster, this is a new service to help AWS, fix their bugs. So it's using Amazon Code Guru to identify potential bugs, and also that to validate, fix, and submit PR back to source projects, which is really cool. So that's an announcement. Cool. On to the serverless announcements, which is what we're all here for, I'm sure. AWS Lambda event filtering. This is amazing. So this is generally available. You can filter incoming messages before invocation. It's the same pattern matching rules as Amazon Event Bridge. You can define up to 5 patterns per event source, mapping up to 2,048 characters each, which is a fair bit of filtering. And batching is applied after filtering. So if we go to the right, you see the CloudFormation YAML that we've got there. You got a batch size of 100. The event source is a Kinesis stream. And it's got this pattern tire pressure is less than 32. So basically, it's the 100 records that are of, where the tire pressure is less than 32, not all tire pressures. So that's kind of how to sort of conceptually understand what that batching means. And effectively, it allows you to have reduced traffic to your function, which means reduced cost. And there's support for Kinesis data streams, Dynamodb streams, and SQS. Cool. So another Lambda one, which is GA, partial batch response for SQS. So you can process information at record level instead of batch level. It'll only retain records which could not be successfully processed, improving processing performance. Removes the need for repetitive data transfer. Imagine you had a bad record in a batch of 100 and, continually tries to process that, which would be super annoying. It's available for both standard and FIFO SQSQ, so and generally available. This is probably my favorite announcement in the serverless space from reInvent, and it's generally available. It's S3 data plane notifications. If you remember, if you wanted to get an S3 event onto EventBridge previously, I think you had to wire it up through CloudTrail, and there was quite a fair amount of latency involved. I think more than 15 minutes or up to 45, something like that. Anyway, this is much, much lower latency because it's a much more direct connection. So it allows you to easily build and deploy event-driven applications without custom software. You can act on new data in S3 faster and make changes to event-driven applications without interruption, and debug by replaying past events. And you only pay for events that match a rule. So if we jump over to here on the right-hand side, you can, pick any bucket in your account or specific buckets by name and the different, specific events like object created and object deleted. So that's pretty awesome. For the Kafka folks in the audience, maybe not super relevant to serverless folks, but AWS Lambda offset lag for MSK and self-managed Kafka basically allows you to manage the performance of your Kafka topics. The offset lag metric is a measure of the total number of messages waiting in the message queue to be set to the target Lambda function. Provides transparency into the amount of data congestion in a message queue, so you can quickly diagnose and solve inefficiencies in data streams. MSK has a bunch of extra metrics as well, so and that's GA, which is really awesome to see. Cool. A pre-announcement in the serverless space, AWS Lambda ephemeral storage. Maybe this could be also useful to James for his game. Provision between 512 megabytes and 10 gigabytes of ephemeral storage in the temp folder. You can provision it in 1 meg increments, available for both zip and container packaging. Customers charge for storage provision beyond half a gig. Default remains the same, no additional charge, and storage is encrypted with an AWS managed key. Cool. So another Amazon Event Bridge feature is cross-region support. So some of you folks run global businesses. So if you wanted to consolidate all of your various Event Bridge event buses into a single region, that's now supported. So allows you to centralize events for auditing and monitoring purposes, or replicate events from source to destination regions to help synchronize data across regions. So that's generally available. AWS Step Functions integration with the Athena console. So serverless data analytics is all the rage at the moment. And so now when you're hopping into your Athena console, it's kind of like a mini Airflow setup. If you've heard of that, you can just kind of orchestrate and manage, maybe you want to send a message before you kick off your Athena query and a message afterwards, you can do a bunch of integrations that way, view interactive diagrams of workflows that incorporate Athena, and launch sample projects. So that's generally available. In terms of AWS step functions, there's another one called Sync Express support for private link. So to keep the security folks happy, if you're in a regulated environment and you're trying to run express workflow step functions from a VPC, you can do that now via private link without traversing the public internet. Great fit with SDK integrations. All you need to do is create a new VPC endpoint, but no other changes are required, and that's generally available. Amazon SQS dead letter queue redrive. So this allows you to effectively manage the lifecycle of unconsumed messages in dead letter queue, standard queues only. Redrive messages to source queue, examine unconsumed messages, recover from errors, reprocess messages. You can easily inspect a sample of messages in the dead letter queue and then move to source queue, and avoid having to write custom reprocessing scripts. And that's, again, generally available. So many GA announcements in the serverless space. I love the serverless team. Amazon SQS managed server-side encryption, and KMS as well. So you can create new queues with SC-SQS or SC-KMS. Allows you to reduce operational burden and complexity in protecting data. SC-SQS alleviates the need for customers to manage their own keys. So that's GA. Cool. So that's all the serverless announcements. Now onto security. We're not going to cover everything, just the specific ones that are relevant to serverless. But AWS WAF, Web Application Firewall, adds support for capture. So that's pretty awesome if you want to annoy your customers. No, it's probably a good thing. This is generally available, so you can easily integrate that with your, API gateways and AppSync. AWS WAF automatic application layer Ddos mitigation. So basically allows you to reduce your time to mitigation and respond to application availability threats immediately. So RAF rules automatically created to mitigate detected DDoS events. Tested against normal traffic to minimize false positives. I just love how, all of this machine learning's just coming on board and, solving a lot of stuff so that, we get to do a hell of a lot less ops. So, it's pretty amazing. It's generally available. No manual intervention required. That is music to my ears. Cool. On the architecture side, I thought this was really important to add because I think sustainability is a big part of the serverless movement. So this well-architected pillar is now generally available. Also with the lenses, there's the extension of guidance offered by AWS well-architected to specific industry and technology domains. So, management and governance, hybrid networking lens, games industry lens, data analytics. So all really good, and that's generally available as well. Okay, so I also am very keen on the data engineering space. So, and that involves supporting analytics. So this is some topics that are very useful to me and a growing number of you as well in the serverless space. There's data exchange APIs generally available. You can interact with them via RESTful and GraphQL APIs to call directly to AWS Data Exchange. Use the SDK in the programming language of your choice. And, you can use IAM to manage access centrally. AWS Lake Formation governed tables grants granular access control, governed tables, which is pretty cool, and storage optimization. So automatically optimize how data is stored and improve query performance as data volumes increases. So this is generally available, and as you can imagine, Glue and Athena are a big part of it. On Athena, there's a preview of Athena ACID transactions. This is built upon the Apache Iceberg table format. So write, delete, update, and time travel operations enables concurrent users to make row-level modifications to Amazon S3 data. Use the Athena's console API, ODBC, JDBC drivers to perform those ACID transactions. There's also the Athena engine upgrade. I just love how AWS does this. Query performance is up to 3 times faster and 70% cheaper without us having to do anything. That's awesome. So that's generally available. So this is a bit more information on the new storage API that solves for those key challenges, like row and cell level permissions, ACID transactions, unified data access APIs. It's amazing. Some of these really bulky services like EMR are now being announced as going serverless, which is incredible. It's simply to use, fast and highly available, highly scalable, and cost effective. You're basically only paying for the resources for the data analytics at scale that you use. So EMR serverless, when it finally goes GA, I think this is going to be a real game changer for those doing massive data analytics at scale. Another one is MSK serverless. So basically Kafka clusters without having to right size cluster capacity, instantly scale IO without worrying about scaling capacity up and down or reassigning partitions, and only pay for the data volume you stream and retain. So that's a preview, which is pretty cool. This is a controversial one because it's not like fully serverless, but Amazon Kinesis data streams on demand. It doesn't scale down to 0, but it'll sort of scale up its capacity units based on the traffic that's coming to your Kinesis data stream. But the end result is it's going to lower your costs pay per gigabyte of data written, read and stored if you've got very highly variable traffic volumes. But as always just check whether it's the right solution for your use case, and that's generally available. Cool. Onto databases. So of the ones that are sort of, I guess, useful to a serverless audience, Amazon DynamoDB standard infrequent access. So imagine you've got a DynamoDB table with a crazy amount of data in it, and very few of those records being accessed quite frequently, but you still need that data there, because you need to provide access to those historical records every once in a while that say your end users access them. That would probably be a good case for infrequent access. Offers 60% lower storage cost than DynamoDB standard tables, no performance trade-offs, and no developer overheads. Sorry, that's generally available. Amazon Redshift serverless is in preview. I think this is absolutely amazing. Automatically provision and scale data warehouse capacity, which means faster time to market. Don't worry about data warehouse management. Pay for what you use. Automatic scaling, compute provisioning, patching, failover, advanced monitoring, backup and recovery, routine maintenance, security, and industry compliance. So, the easy start experience developer and business analyst can activate Amazon Redshift serverless for your AWS account, connect your favorite BI tool, or use the Amazon Redshift query editor, load data seamlessly, and Redshift will do the rest, and just pay for compute and storage use during analysis. So that's all in preview. Cool. Onto the Aws ML Stack, because a lot of you probably aren't building machine learning models, but you want to leverage some of the APIs that AWS are offering, one of which is Amazon Textract. So it's announced generally available specialized support for identity documents. So imagine you've got a passport and it'll just spit out a JSON object of all of the data in that particular document. Another one that's gone GA is Amazon Personalize Intelligent User Segmentation. So allows you to identify user interested in a genre, category, or any other item attribute. Benefits are like more effective marketing campaigns. So that's all pretty good. A bit more information on it, like use case optimized recommenders for retail, media and entertainment. So recommended for you, sort of, in your shopping cart and stuff like that, and top picks for you in media and entertainment and the like. So that's really cool. And Amazon Kendra, it's got this new feature called Custom Document Enricher. You've got this AWS Lambda function that can call out to recognition to extract, transcribe, and comprehend to enrich your search index. It's also got this experience builder, so you can construct your end search dashboards with UI components. These are all generally available. And your search analytics dashboard, so you can see what sort of usage you're getting off Amazon Kendra, again, all generally available. And then one that's in preview is Amazon Lex. You've got an automated chatbot designer, so analyze thousands of lines of transcripts in minutes, accelerate chatbot deployment, and improve your customer experience. So I know that was a whirlwind tour of, I guess, all that's on offer in the serverless landscape. Well, according to me, all of the, sort of serverless relevant reInvent announcements, I hope you got a lot out of it. I certainly enjoyed presenting it to you. I think, I'm really keen to find out, what were your favorite picks and what you're going to, have a go over the next couple of months, maybe integrate into your, either your hobby side projects or your production workloads at work and stuff like that. So thanks once again. We're on next month. I promise we'll get you a meetup to you next month. But as always, we're always on the lookout for new speakers. So if you want to reach out, peter@cloudshuttle.com.au, all of you are most welcome. Mossen said the CloudFront part, and Scott Scoville, SQS dead letter Q redrive. That's his favorite of the announcements. So awesome that you're finding that quite useful. Scott's also said the Event Bridge S3 notifications without CloudTrail API is a really good one. And Daniel Zivkovic said, thank you to me. Well, really appreciate it. Thank you that you found this all really useful, and hopefully you'll be coming back in a couple of months and presenting at the meetup with some of the cool new services that you've tried out and built solutions with. So thanks once again. Ciao for now. See you next month. Awesome. Bye.